right. Sweet. Okay. So are you starting the broadcast?
Mm-hmm.
You're just going to post it, right?
Yeah.
Okay. Sweet. So we're on lesson 4, group problems. So for number 1, it's talking about the 2 traits, the garden peas, the cotyledon color, and the pod shape. So for A, it's asking for a null hypothesis to test the chi-square. So the null hypothesis would be that it is a green, let me keep trying. Null hypothesis is the green cotyledons and the constricted pods are dominant, because we saw that in the self-fertilized F1 plants in the first generation were all that, and then it changed as it continued. So then B, for the chi-square test, I don't know if I can switch this around, but I can. Maybe. Nope, never mind. So okay, I can. So for the chi-square test, what I kind of have here. So we can see that for the first one, it's about a 50% rate. The second one, it's about a 25% rate, and then a 21% rate, and then a 4% rate. So as the chi-square test goes on, we have to times it by the total number. So these are the numbers I got. The 563, and then the 281.5 or 282, and the 236 or 237, and then 45. So going through the chi-square test, we have to do the observed minus the expected squared over the expected for each one of those 4. So total comes out to this 0.0018 plus 0.032 plus 0.105 plus 0.09, which comes out to 0.229, which is our results for the chi-square test. At least that's what I got. And so for, sorry, what?
Oh, I'm just looking at your work real quick.
Oh, yeah. Sorry.
You're fine.
So that's kind of what I got for the chi-square test, which I'm pretty confident on. I've done quite a few chi-square tests in my biology classes. But if you guys got something different, I'm totally open to hearing what you got. But because the chi-square test is in the 0.229, 0.23 range, the null hypothesis is accepted. So that's for C.
Okay. So I don't understand how to do is it chi-square? Is that how you say it?
Yeah.
They confuse me. That's why I was like, I have 2, but I have half of 2 because I don't understand the other half.
Yeah. So I have like A and B of 2, but yeah, like you said, C and D, I wasn't able to get to yet.
Yeah.
I did 3, 4, and 5.
Maybe we can get some teamwork then.
Yeah. I started doing the chi-square test for C on number 2. On the null hypothesis, so doing the chi-square test, and it's odd because it honestly just comes out as 0 for all of it. I can't figure out how to get the numbers, because you should come out to like a certain point something, but it literally just comes out to 0 for me. I don't know what I'm doing wrong, I guess. So yeah, C is a mystery. C and D for number 2 are a mystery for me, which I wasn't able. I even went to the tutoring center today, and they were like, I have no idea how to do this. And I was like, you're the tutors.
Oh.
So,
oh my goodness.
Yeah, I don't know.
We're doomed.
No.
Yeah, so
you can always board. to see if anyone else had problems on it.
Yeah, that's true.
Yeah.
Good
I
idea.
don't get it that
Oh.
much either.
At least we're all on the same page.
Get a ding on that one. I don't know.
Study for the test
All
was
right.
to like,
What did
watch all the videos or like try
Yeah.
to go through.
That's probably what I'll do too.
I don't know because
What
I
did you
just like
guys
I
get
feel like
for
I learned better from a video than reading.
Oh yeah. What did you guys get for A and B for number 2?
I was thinking A was codominance, but I wasn't positive about it.
Let me find where my work went.
Does that make sense? I was thinking it's
Yeah.
similar to like that pink, where you have the red and the white coming together, but this case you get spots.
Yeah, I got codominant for A.
That's good.
Yay! And then for B, I got that 50% of the females would be normal,
Yeah.
being heterozygous, and then the males would also be normal. And I just put 50% for that. But all of the mice would have black and white spots.
Yep. That's
They'd
what
all
I
be
got.
heterozygous.
Yeah, no worries. Sweet.
Mm-hmm.
You're going so far. Okay, this is
All right. So then C and D. Any ideas how we should start it?
Nope.
At least it says that we don't have to necessarily do the null hypothesis. We just have to do this the chi-squared value, which I don't know what that necessarily means. Like that word throws me off.
Which word? Sorry.
Where it says instead of being like, I don't know, they have all these other. Oh, I guess maybe it's the same as A then, or B. Instead of just going straight to figuring out a null hypothesis, or sorry, A on number 1, we're just doing B, I guess, for question number 2, part C.
For question number, you're doing C?
Yeah, on number 2.
I can go in there.
Don't go in there. I get you.
Okay. We're trying to figure out.
I'm gonna go back to the notes and see if there's anything that helps.
Okay.
Okay.
My forehead.
Could it be that our sample size is too small?
Oh.
That's exactly why I keep getting zeros, because the sample size is so small. And so there's not much probability that we can get
I think that
accurate chi-square test.
Yeah, I think that the answer probably is 0. I would assume so, since you've got a lot of progress or practice. Mm-hmm. And that it's probably just we would have to reject the null hypothesis because the sample size is too small. Yeah, because you have to have at least a sample size of 30, I think.
Yes.
To do anything.
Or more.
Yeah.
Yeah.
It comes to a total
let's just roll with that.
Okay.
Nice.
Because I've never worked with a chi-square test that's less than anything, at least 30. Most of them tend to be at least 50 or more.
Yeah. Do you have your work by any chance on how you got the 0?
Yeah. Mm-hmm.
I might have mine too.
I didn't finish it. Well, okay, so what I got, so I started calculating it out, the percentages at least. And so it comes out, go ahead and switch this around. So what I got, so you can kind of see that it starts out, so for the very first one, it's 12%, 42%, 15%, 12%, and then 19%. But if you times that out to get your observed number, they come out to the exact same number as what is already listed. So they're the same number. So you would basically just do 3 minus 3, 11 minus 11, and then divided by 11. And so it all just comes out to 0.
Okay.
So that's kind of what I got. Yeah, I started doing the work and then I was like, well, there's no point because they're the same numbers.
Okay. Yeah, I would assume that it's just because our sample size is so small.
Yeah.
So
okay.
You're probably getting it right.
Yeah.
Let's go with that.
That's my one little bit of that's all that my biostats helped me, and that's it. That's all I got.
Yeah.
Yay.
That's all I got. Okay. Number 3. Was anyone able to get 3? Because I think I got it, but I did it right.
So I definitely don't have 3. I got off work late today and didn't have time to do it. But I've got 4 and 5.
Okay, so
for number 3, I got 0. 3A, I got 0, but I'm trying to figure out how I got 0.
Okay, I got 9/16 chance. But how I got that, so I can kind of show you the work that I did for that one. So obviously I have the Punnett squares for the 2 separate rates. So for
A, wait, we're on number 4. Wait, no.
Oh, is this 4? No, 3. Sorry, I wrote 4, but I meant 3. Sorry about that. It's my bad.
Or no, that.
Yeah. So for A, it's asking for the first 5 offspring that have small grins that can disappear. Mm-hmm. So we're looking at the probability for that. And so obviously, because the first trait is a 3/4 probability of having small grins, first 5, let's see. Probability of the first 5 offspring will have small grins that can disappear. Yeah, small grins. So I got a 3/4 times 3/4 probability, which equals 9/16.
Mm-hmm.
So that's what I got. Or actually, Yep. Right? Yes. And again, I'm not 100% sure that's right, but from what I understood from the note, that's kind of what I was like looking at. So
we're just literally looking for percentages.
Yeah.
Okay. Something you're going, I need to figure out a lot, and I'm like, I don't know how to do that.
You just kind of do the square and then just multiply it.
Okay.
Yeah.
Okay, what did y'all get for B?
It's B. I got a 9 out of 256 chance. What I did is I timed the 9 by 16 times 1/16 and got a 9 by 256 chance.
Okay. What about C?
C, I got a 3 out of 256 chance because you're timesing the 1/4 by 3/4, which equals 3/16, and then the 1/4 by 1/4, which equals 1/16. So you times the 3/16 by the 1/16 to get 3 out of 256.
Nice.
And I guess I could put these into percentages. I should maybe figure that out, but
It's not so hard to do.
Yeah.
What's D?
Yep. Yeah, and then for D, I got 9 out of 256, which I guess is the same answer as B, but for that one, the work would be you'd have 3/4, which is 9/16, and then 1/4 times 1/4, which is 1/16, and then you times the 9/16 by the 1/16 to get 9 out of 250.
Okay.
Let's see, 9 divided by 256. So that would be about 4%-ish.
Yeah,
Perfect.
I got that.
Okay.
I think. I'm like,
Yep.
Okay, I can do 4 if y'all want.
yeah.
Yeah.
I think up on a little bit because I was getting confused.
Okay, so I actually
You
was
get it?
also getting confused, so I went and watched other people's videos
Yeah.
to check what they got, because by now there's a couple of people who've already posted them. But that's my fancy trick to figuring out how to do stuff. For the first one, I got that it was autosomal dominant because it affects every generation. It affects both males and females, and males can pass it on to both male and female offspring.
Yep.
So that's what I put for that.
Uh-huh.
For B, I got Y-linked because it's only males that are affected, and it's inherited from father to male, and 100% of the male offspring are affected.
That's what I
Yeah.
got.
For C, I got X-linked recessive because of generation skipping, and it's passed from father to male offspring as well.
Wait, say that again. What was?
It's X-linked recessive
Oh, darn. Okay.
because it skips generations and can pass from father to male and female.
Okay.
I think. Yeah. Okay. And then for D, I also got X-linked recessive. Again, because it skips a generation, females are carriers, passed on from fathers. E, I got autosomal recessive. Both males and females are effective, and it skips a generation.
What I got.
Perfect.
Sweet.
I can get 5 or someone else can. It doesn't matter to me.
If you want, you can go for it. I got some of them too. I just have the answers written down, so I need to put them with the question again.
Okay.
For the
All of them.
I got the sum probability rule is used for mutually exclusive events, while the chi-square test compares the observed outcome of a genetic cross.
What I got.
So the sum and chi-square test are what I got.
Okay, for that one, I got the product and the chi-square test, but I could also be wrong. So.
And for B, I got X-linked recessive and then X-linked dominant.
Yep.
That's what I got.
Okay. And then for C, I got the sum rule.
Yep.
It uses OR. D, I got independent.
That was
That's
the
what's
one
used to describe events that have no influence on each other.
Yep.
Mm-hmm.
E is autosomal inheritance, and then Y-linked inheritance.
Mm-hmm.
F, I got sample size. And then for G, I got degrees of freedom.
That's what I got.
Perfect.
Sweet. Awesome. Well, good luck on the test, you guys.
Huh?
I said good luck on the test.
Right.
Yeah.
Hopefully they don't have a lot of these questions on it. Hopefully it's from the other sections.
Yeah.
No problem. I don't know. I'm just gonna rewatch videos because I think that'll help. Because I've read the notes a lot.
Mm-hmm.
Obviously, I don't understand it that well, but videos normally help. and some of them
Yeah.
are pretty good. So, okay, we'll
Alrighty.
see you guys same time.
Yep.
Yep.
Okay,
Works for
good.
me.
Have a-
All right.
See ya, bye.
guys.
Bye.